Welcome to the Boba Fett chest display full resolution bar graph build video. You can find parts on my store page, Westaby Electronics. See the video description. The major difference of this kit that we're going to be putting together is that every bar of the bar graph is animated, which is pretty great, and you can do some really cool animations. So let's get to it. We have the parts of the kit here. And if you don't have the exact right resistors or exact right transistors, that's fine. At the end of the video, we'll get into part substitutions. But using the parts we have here, let's just talk about, this is the main PCB. You have to order this from a PCB manufacturer or myself. And same thing with the bar graph PCB. And they're two separate pieces, so then we can have a cable that connects them. And depending on what build you have, you can have varying window sizes and it'll always fit. You don't have to make the window fit. You can have the circuit fit what you have. And here's the cable that makes that happen. We'll be assembling that later. Have some NPN resistors, and we have an assortment of resistors and a capacitor. Let's clear this and start working on what we need is really a chip. So this is the ATtiny 4313. And the 2313 would work just as well. If you buy it from me, I generally use the 4313, and these chips need to be programmed before being installed on the circuit board. To install the chip on the circuit board here, you need to look carefully at the circuit board itself, and you'll notice a marking for the ATtiny, and you'll notice on the end there's a notch. And if you look at the chip, you'll see there's also a notch on the chip. What we need to do is align these parts and push them together. And they will stay reasonably put together, but flip it upside down and we'll get ready for soldering. So to get ready for soldering, you're going to want a pair of safety glasses. You'll need a solder iron. I use a temperature controlled solder iron, but a $5 one from the hardware store will work just as well. You'll need a pair of flush cutters, again $2 part from the hardware store, and then you'll need a roll of solder. We can see that there are the different pads here. Let's take a closer look. For the soldering, what we're going to do is put our iron tip on there, bring in the solder, and just enough to build it in. And you can see that it's dried, it's nice and shiny. After one or two pins, you can flip it over and make sure that the chip is still aligned and hasn't fallen out. So now we can do the rest of them. Each one has its own amount of solder. They're not bridged, or nothing is touching any of the other pads. So the accompanying parts for the chip are a 10k ohm resistor and a small capacitor. 0.1 microfarad is a good choice. You can see the capacitor here, and you can see the spots here that say 0.1 microfarad. And when I bring in the capacitor, you can see it doesn't quite fit, so we'll have to bend the leads to make it fit that spot. And we'll push it through, and we'll come to the other side and solder it. So you can see that the left one has enough solder on it, but the right one, I can still see the hole. That is not enough solder, so I'm going to come in and add some more. And now I can see that there is shiny solder all the way down to the board. To clean it up, I just come with the flush cutters. And that's a good solder joint. Now we can add the 10k ohm resistor, and this one will slide right into the board. And if you turn the board around, you can read a spot that says 10k ohm in the corner. That's 10k. We're gonna insert the resistor and bend the leads a little so it doesn't fall out, and flip it over. Same thing, we'll come in with the flush cutters, flip it back over, and we can see that we have our resistor, we have our capacitor. Excellent. We're doing really good so far. For the next part, we're going to be putting on the resistors. The resistors, you can see, is 1K and 50, and then there's 5 pairs of those across the top. And the actual numbers are not important. It says 1K ohm and 50 ohm. I'm going to be using 500 ohm and 90 ohms, and any other value that is close will work. For the 50 ohm, anything around 50 is just fine. 33, 47, these are all common values. Same thing with the 1K, but if you have 500 or 333 ohm, those are all great. Let's install these resistors, and you'll notice that mine are different colored. Yours will probably be all the same colored. It doesn't matter. Different sizes, again, doesn't matter. I'm going to go through and install all the 500s, then I'm going to go through and install all the 90 ohms. Okay, I've poked them all through. I'm just going to bend them into place, and we can flip it over and solder those joints. The important thing to note when you're soldering these is to not bridge the nearby solder joints. Okay, with all those soldered, we'll flip it back over. Make sure that nothing's jumped out of place. I can see that this one has raised a little bit, but nothing is blocking my access to the other pins. I see one that I'm going to adjust with the pliers, a little bit more centered. Seeing that everything looks good, we can use the flush cutters to remove the ending pins. Flipping it back over, now we can do the 50 ohms. Again, I'll be using 90s, and it doesn't matter. Flip it back over, bend the leads. It's a little bit tricky to hold the solder iron in between the different pins and only get solder on the one we want, but it's really not too bad. Everything looks just fine all the way down the row. We take the flush cutters again, remove our pins. The next thing we're going to be installing is the transistors. I have here two N3904s, which are standard general purpose NPN transistors. The actual build calls for 2N4401. Those are not particularly necessary, they're just easy to find. So if you're building from scratch, get those. If not, use what you got. General purpose NPN is what you want. When we look at the board, you can see that these half moon shapes are where the transistors will fit, and the 3 pins go in a row. Front, back, front. You can see that the transistor matches that half moon shape. Before we solder it, what I like to do to make this a slimmer profile is to push and lay down the transistor. By laying it on its back, I give myself a more slim profile of the circuit board. And I can see my 3 good solder joints there. Flip it back over, and I can see my NPN transistor is exactly where it should be. Nothing's shorted, good solder on everything. So I'm going to repeat that for the other 4. That looks ready to solder. Flip it over. When I do a bunch of parts in batch, I like to solder a single joint on each one, flip it over, and double check that everything still looks good. If I need to adjust something with the pliers, now is the time to do it. Come back and solder the other points. All the transistors are soldered, everything looks good. So the last part for this board are the character displays, are mounted like this here. So let's put the other ones on. There we are. And you can see on the bottom, the dot is in the lower right corner, and the chip is down here. As I flip this over, these guys are going to want to fall out, so just hold them with your fingers and then flip it over carefully. And keep everything pushed down because they are very loose in those sockets. Only soldering a single joint is going to allow me to flip it over and adjust the positioning so I can look here and see how good I did. And I can see that this guy right here is kind of crooked. Before I solder the rest, I'm going to take the pliers and just adjust so he's a little more straight. So now that all the character displays are aligned across the face, we can go back and solder the other 45 solder points. With the pins in between the resistors, you have to come in from a high angle to get enough heat on the pin and the pad at the same time with your iron. And if you look at the angle of my solder iron, I'm holding it very high to reach in between the resistors. I want to touch the pin and the pad with my solder iron, but nothing else. And the high angle allows me to do that. Okay, just going across the board, we can look for anything that looks askew. We're looking for things that don't have enough solder. We're looking for things that have too much solder. We're looking for 2 points that might be connected that shouldn't be. We're looking for things that are not connected at all. And this all looks very good to me. I can see that no 2 points are connected, and I can see that every point has solder on it and looks just great. This board is now complete, and we can start on the bar graph board. The bar graph board is labeled on either side. You can see that there's a plus and you can see that there's a minus. If you have a different part number than the Kingsbrite that I have here, your plus and minus might be different. So in order to test this, all we need to do is have a battery pack and a resistor. We'll hold the resistor with the wire here, and we'll only touch the display through the resistor. On this one, the side with the writing is positive, so when I touch it with the positive side through the resistor, and there, I can see that it lights up. Now that we've established that the writing side is the plus side, we can install it in line with the plus symbol on the circuit board itself, and we install it with the bars facing the markings here. I'll look at the back and I can see the plus symbol and I can see the writing are on the same side. The minus symbol and the non-writing are on the same side. And I can install this bar graph the same way. So we can solder these here. Another 40 solder points. Okay, we're done here, but there's a mistake. Let's take a look at that. And if you look here, I have a bridge connection, so we're going to have to clear that up. And the thing about soldering, solder always wants to travel towards the iron, so I'll hold it over here, and I'll hold it over here, and you can see it separate. The other thing you can do is put the iron between them and then quickly move it away. We're in the home stretch. So now we have our bar graph circuit and we have our main character circuit. To attach them, we're going to attach them with a ribbon cable. You don't have to use the ribbon cable. You can solder the individual points together, keeping 1 to 1, 2 to 2, and so on. The ribbon cable makes shorthand of this. In the part list, I have a 2x3 socket, but I'm just going to be using the straight stick socket and cutting them into 3-pin segments. I'm going to be taking these and sticking them into the connector here. So what that's going to do is allow me to line it when I stick it into the circuit so they stay put when I solder them. Okay, with it soldered, I'm going to pull this off, leaving my bare socket here ready to be plugged into by the cable later. And I'm going to repeat that on the back of the bar graph. I got another 3 pins off of my straight pin header and put them in the back here. And then put my connector on. And again, the connector I'm inserting just to hold the pins in while I'm doing the soldering. To assemble the ribbon cable, it's quite easy. You just insert the ribbon cable into the connector and pinch them shut. You can do this by hand, hit it hammer, or pliers in this case. And we can cut off the excess if we want. With one socket on, we're going to slide it on here, and then we're going to measure how much distance we want between the bar graph and the character display. And cut it a little long because you can always pinch down the cable later to adjust it. So I'm going to measure this one at about a 1/2 inch apart. With it measured and trimmed, we can install the second socket here. And this is important. Both of the sockets need to face the same way. If there's one up and one down, that'll actually reverse all the wiring. We don't want that. We want it to both be facing the exact same direction, like this. Just a couple of light taps is enough to seal the connector. We can plug the two boards into each other, and that is one completed circuit. Bring our batteries back in so we can turn this on. We'll remove the cable so we can install the battery connections. So on the edge of the board, you'll see a marking that says 4.5 volt, and there's a tiny plus and a tiny minus. The plus is going to be the red wire, and the minus is going to be the black wire. Put solder on the wire and joint separately. You can solder them together to give you a good joint. Now these wire connections, they will fail over time with strain of pulling on them. I recommend covering this whole thing with hot glue to provide wire relief. So let's turn it on and see what happens. Oh, so I forgot to program this chip. So let's do that now. And I use a AVR ISP device here to do my programming. You could use Arduino just as easily. Google search for it. Anyone who buys chips from me, they will come pre-programmed with whatever animation you want. Let's program this chip. Oh, I noticed a mistake. Can you see my mistake? I'll switch to the microscope so we can look at this. So while I was hooking up the programmer, I noticed a mistake. This pin over here is the display connector. This one over here is an unmarked connector where I put my pin header. That's the programming pin header. Oops. It didn't hurt anything. And it's easy enough. I'm just going to install another connector over here, another pin header, so we can connect the ribbon cable there. We'll do that later. For now, we're going to use that pin header to connect to our AVR ISP. Back in the Arduino software, we can select our board, make sure the right board package is installed, and the @tiny board package is just a normal one you can install using the board manager. Under programmer, I've selected the AVR ISP, which is my programmer here. So then when I click here and say upload using programmer, it's going to come through and it's going to compile the sketch. Then it's going to use my programmer here to do the job. Compiling, uploading. And there it's uploading. And it's done. And if I flip this guy back over, oh, look at that. Hey, it's working. Woohoo! Putting away the ISP programmer and coming back in with our bar graph. I just need another straight pin header, glasses on, to do some final soldering. And I'm going to use the cable to hold them in place so they don't fall out. Come in with the solder iron. Now, when I plug in my bar graph and flip this on, oh, look at that. And you can see that the bar graph is racing back and forth with a Larson scanner style animation. So putting it behind a window I prepared, we can see what it looks like installed. Oh, that's rad. That's really great. Awesome. This is really slick. Awesome. And that completes the build video. Thank you for joining us, guys. That's all I have for the build video, but stick around and we'll talk about some different part selections. Okay, so talking about some different part selections, you can see on the back of here that we have the resistors and we have the transistors. And I've said throughout the video that the specific values that we choose for these things doesn't really matter. The screen's still going to be reasonably bright. Lower values means a brighter display. We're running on a battery pack and the current output of the battery pack is limited, and that's the real limiting factor of the brightness of the display is the battery choice. But beyond that, taking this apart and we can look at the resistors, I have another circuit prepared here. Let's take a look at that one. So on the back of this one here, and it's green, but this is the exact same circuit. There's nothing special or different about this guy. Let's take a closer look at this other circuit I have prepared. And this is the exact same circuit, but I've actually assembled it without the resistors. So under 1K, I've shorted those. Each one has a pin wire there instead of a resistor. Down in the transistors, I've shorted the first forward and back pin on each one. This circuit works normally. It's the same brightness as the other one. There's nothing special about it, except I've soldered it together without the transistors. I've soldered it without the resistors, and it works just fine. So if you can't find a specific resistor or transistor, don't worry about it. You can build it without it, just as easy. That's it. Thanks for stopping by, guys. How'd you like my video? It was nice. I work really hard on these circuits, and I really like these Boba Fett displays. I call them a full resolution display because each bar is animated individually. The previous kits I sold did not. They were animated. There was 5 blocked sections on here, and I would light those blocks of bar up. So you'd get a bar here, and you get a blocky bar here, and there were 4 wide, so they'd jump around. And the new ones can do that too, but because each individual LED bar here is individually addressed and individually animatable, it gives us a lot more ability to go all out. Really, I think this is just great.